Hey everybody, the purpose of this video is to walk you through the calculation of Pearson's second skew coefficient for the data given in E4, which is this little graph here, the bimodal graph that we talked about in class back with center. So just wanted to show you how to kind of crunch that through your machine. Here is the data in the distribution with the proper assumptions, 55, 65, 75, and so forth, dropped into L1, and the frequencies dropped here in L2. So what we're going to do first is we're going to drop out of here. I've already hit calculate, but I'm going to do it again because I interrupted it. We're going to calculate 1var statistics on said data. And you'll notice the average comes out as 74 with a sample standard deviation of 15 and a median of 75. Now you might notice there's a difference. This says mean is 71, median is 78. You might be concerned that there's a difference between the values that are coming back from the TI over here and the values we're getting up here in the parameters. The only reason, quite simply, is because these parameters up here were gotten by the actual raw data that I had, not grouped like this. I grouped it like this to show you, basically A, B, C, D, and F, not necessarily the individual A's, individual B's. So there's a little bit of deviation, but not that big of a deal. Okay, so now that we've got that, we are now going to use the stored values of the average, median, and standard deviation, and we're going to calculate Pearson's. Okay, so we're going to do this again. It might seem a little quick, and if it does, that's totally fine, but you've got the reference back in E2 where I walk through this much more slowly. I actually can't believe I can do this and talk at the same time. That is very unlike me to be able to. I'm probably screwing it up. No, I'm kidding. I'm not screwing it up. Statistics, standard deviation is 3. There's Pearson's right there. We press enter, and we come up with a skew coefficient of slightly negative 0.05. Now, one can look at that and say it's very close to 0, so therefore the skew on this data is very light. And honestly, the skew is fairly light because the average is centered, and this is fairly symmetric data. But you got to remember, very often the assumption is if the skew is little, then it's a bell-shaped distribution. No, it's not. It's definitely not a bell-shaped distribution. It might be roughly symmetric, but it sure isn't bell-shaped. So that's why you don't want to blindly apply formulas without first looking at the shape of the data. All the cool tools we're going to learn in this class, all of them, fall flat on their face if you don't start by looking at the shape of your data first and making decisions based on that. All right, I hope that helped, and we'll catch you in class.